Lesson 9-7, page 316 from your math journal. Here we have earth, water, surface. And what we're looking at here, boys and girls, is estimates. And to see if you can make a reasonable estimate on what you think, how much water there is on the surface of the earth. You can make your own estimate and explain here why you think it is. Take a look at the big oceans, such as the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, the Arctic, okay, the South Sea, and estimate. Give us an estimate just by looking at a world map. Next, we have to write a sample experiment. For example, it's going to ask you what your location is at latitude and longitude. Take a look at this world map. What we're looking at here is the lines, latitude lines, latitude go horizontally, okay? And longitude go vertically, okay? What we did here is we made a grid and we placed it on the earth. Now these lines don't really exist on earth, boys and girls. I think that should go without being mentioned. But just so that you know, we've taken the world map and we put a grid on it so that we can find coordinates the same way that we do in class when we're playing Battleship or the hidden treasure game. Well, here, let's say it's asking where we are longitude. Well, locate Venezuela, and it's right there, okay, right in the center there. And let's find the coordinates for Venezuela. First we look at horizontally and then vertically. Horizontally and vertically. Okay, horizontally, here's the equator, which is 0. Okay, the equator. And then we move up, and at 15 degrees, it goes above Venezuela. So it's got to be about less. I am going to estimate that it's somewhere between around 10 or 12. If we were to draw a line, it would look like that. So it's around just above 10 perhaps, or maybe right on 10. Okay? That's where we would be because Valencia is right there. Okay? And then vertically, well, we have 60 and 70 here at the top. So let's see if we were to draw a line straight down like that. Okay? We could say that we're located somewhere between 60 and 75. 67, perhaps 65. Okay, I'll let you make that estimate. So go ahead and fill those out right here in your latitude and your longitude. Okay. Circle 1 is your location on land or on water. Well, we're obviously up in the mountains in Valencia, so we're on land. And what fraction of the class is on water? I don't think anybody here lives on water. Okay. So that fraction would be 0. Out of the number of class students, so 0 out of, how many students are here? 19. And when we get Maria Victoria back, it'll be 20. Percent of Earth's surface that is covered by water. Wow, how many people? Percent of Earth's surface covered by water. Class estimate. This we will do tomorrow. Okay, we will see what everybody estimated. For question 3, it's asking the actual percent of the surface of Earth that's covered by water. So percent of Earth's surface that is covered by water. Actual figure. I would recommend that you go on Google and type in this right here as your title. Percent of Earth's surface covered by water. Go ahead and type that in. I did my Google search and I'll show you what I found. I found that oceans. The ocean covers 71% of the Earth's surface and contains 97% of the planet's water. So 97% of our water is undrinkable. It's salt water. And it's telling us here that 71% of it covers the Earth's surface. Now this is just oceans. Don't forget we also have lakes and rivers. So you could add a little bit more to that, but this is the big bulk of it. Okay? This is very interesting. Yet more than 95% of the underwater world remains unexplored. 95% remains unexplored. It means we don't really know everything that's underwater. The ocean and lakes play an integral role in many of the Earth's systems, including climate and weather. That's right. You know that our climate is affected by the amount of water available. I found this information at www.noaa.gov/ocean.html. Now, NOAA stands for National Oceanic and Atmospheric Administration. On page 317, we're going to play a little math game where we are trying to follow these rules to create equivalent expressions. For example, 1 is going to equal, and you have to write an equation using 4 fours. So here are the rules. Okay, rule number 1, you must use 4 fours in every expression. 4 fours. You can use 2 fours represented as 44, that would count as 2, or 4 over 4, which is 1. Okay? You may also use 4 to the power of 0, which is also 1. And you may use square root of 4, which we all know it's 2, the value of 2. And this is a new one. You may use 4 exclamation, 4 factorial, which actually stands for every number counting down from 4 as multiplication. Okay, factoring. So 4 times 3 times 2 times 1. That's what this means. Challenge yourself and go ahead and use that. And you may also use 4/10 or 0.4. Okay, you may also use it as a decimal. Go ahead and try that like we did in class. I look forward to your answers and your different combinations. Continue with the same activity on page 318 right up until also page 319 up until number 100. For the second half of page 319, we will do the same game, except now we are doing it with sixes. So it says here is using only sixes, or 6 sixes, and any operation you'd like. Okay, create expressions for values from 1 to 5. Now don't bother using a calculator. You can do these in your heads. Okay, and here we have an example. 1, 2, 3, 4, 5, 6. 6 sixes. And when you calculate all of this, you will get 4. Try that from 1 to 25. If you watch the video, you will have this answer right here for number 10. 6 plus 6 is 12 minus 1 minus 1, which equals 10. You will also have the answer for number 23. 6 times 6 is 36 minus 12, which you see here, 6 plus 6. So 36 minus 12 is 24, minus 1 is 23. Okay, you will have both of these answers tomorrow exactly this way, and that's how I will know that you watched the video. See you in class.